All right, I'm out here at the Pumice Desert. This is a really cool area, a little north of the lake, probably about 8 miles or so. Not much vegetation out here because there was a major pyroclastic flow that left during the major eruption of Mount Mazama. And this flow came right in here and deposited a bunch of pumice. Okay, first of all, what is a pyroclastic flow? Well, during the volcanic eruption, this explosive eruption that happened, a lot of heat was sent up from the vents of the volcano, and if it wasn't hot enough, it couldn't actually go vertically. So if it's really hot air, that's really less low density air, right? Hot air is less dense than cold air, and that will shoot up vertically, create that huge plume. But some of it isn't hot enough to actually go vertically, and so it ends up just spreading out along the surface of the earth. There's ash in there, there's gas in there, a bunch of nasty stuff you don't want to encounter, and it can go really fast. It can go between 60 and 400 miles an hour. This stuff can come at you. And it deposited pumice. Pumice, what the heck is that? Well, pumice is this really interesting rock. This stuff actually floats in water. Pretty cool. And the reason why that's true is because it has air bubbles that got trapped in there. So there's this gas that is within the magma. Once it encounters lower pressure, this gas can actually get outside of the magma. It's not dissolved gas, but it's actually trying to escape, just like carbon dioxide escapes soda. You see the gas bubbles shoot up. But there can be some gas bubbles that get stuck in that magma. So from this liquid magma, it'll turn into hard rock. And any gas that gets stuck in the magma ends up creating air bubbles in the rock. And so this rock becomes pretty low density stuff. All right. Earlier on, I was checking out pumice. Now I'm eating hummus. It's a pumice and hummus kind of day. All right.